Hello students, how are you all? I hope all of you are doing very well. This is Prema here and this is my channel Simma Academy. So today I am here to take a session on a very important chapter of mathematics, that is trigonometry. So you might have seen long ladders against a wall or tall buildings or poles, etc. Okay, so have you ever wondered how do we find the height of these buildings or these tall structures without actually climbing them? Or say your school wants to install a CCTV camera at the top of the building. So do you think they are going to climb up the building and see the height of the building? No, right? So here mathematics play a smarter role, and the chapter which helps us is trigonometry. So what is trigonometry? So it is a very fascinating branch of mathematics which deals with the relationship between sides and angles, okay, of right angle triangle. Okay, we have right angle triangle. Okay, so primarily in 10th standard you will be dealing with the right angle triangle. Okay, so trigonometry, the name trigonometry, it comes from the Greek word, okay, where trigonon means triangle and metron means measure. Okay, so this is the branch of mathematics which deals with the measurement of the sides or the angles of the right angle triangle. Okay, so what is the learning outcome here? What you're going to learn after this session is number one, you will be able to identify right angle triangle. Okay, second thing, you will be able to locate, or you will be able to name the sides with respect to the angles. Okay, and third thing, you will be able to define trigonometric ratios. Okay, so these are the three things we are going to learn in today's session. So let's get started with this topic. So before starting the actual topic of trigonometry, let me give you some prior knowledge that you already must have learnt. Okay, so what is a right angle triangle? What is a right angled triangle? I hope all of you must be knowing that. So right angle triangle is a triangle where you have one angle 90 degree. Okay, I name it as A, B, C. So here one angle has to be measure 90 degree. Okay, the other two angles will be the acute angles. Okay, the other two angles cannot be more than acute angles. That means they cannot be more than 90 degree because some of the angles of the triangle cannot exceed 180 degrees. Okay, so this angle we can name it theta. This angle also we can name it as theta. Okay, so the acute angles I will represent as theta. Okay, this is called theta. This is a symbol for theta. Okay, like this. Alright, so right angle triangle where one of the angle is 90 degree. Now when you draw a 90 degree angle, so the side opposite, so here we have the longest side. So this is the longest side which is opposite to the right angle. So the longest side is called as hypotenuse. Okay, and the other two sides can be called as perpendicular and base. Okay, so how I'll explain you how do we proceed with it. So here step 1. So if you draw a right angle triangle, as I said already, we have a 90 degree angle. Okay, and the side opposite to this is the hypotenuse, and the acute angles will be theta. One of the acute angle I am marking as theta. Okay, now step 2, Step 2, how do you name the sides with respect to the acute angles? Okay, so the side opposite to theta, that means the side opposite to acute angle is always called as perpendicular, or you can also write it as opposite. Okay, or the side adjacent to theta is called as the base, or you can call it as adjacent. So when you're marking, you can use it as either perpendicular or base, or you can use it as opposite or adjacent. So here if you see here, so hypotenuse is never going to change. Hypotenuse is the side always remains the same. Here hypotenuse is AC because it is opposite to 90 degree angle. Only the adjacent and the opposites will change. So here if I am marking theta is here, this is the acute angle which I am marking here. So opposite to that, side opposite to theta is perpendicular. So this will be called as the opposite or the perpendicular, and this side which is adjacent, just adjacent to theta, is called as the adjacent. Okay, or the base. This will be base or this will be perpendicular. Okay, so this is how we name, we identify the opposite and the adjacent. Okay, step 3 will be identifying trigonometric ratios. How do we define trigonometric ratios? Okay, how do we name them? So trigonometric ratios are the ratios of the sides of right angle triangle, okay, with respect to the acute angle. Okay, so here this is very important point. Okay, this is very important in terms of your board exams. You should be able to identify when you are studying trigonometry. First thing you have to be, you should be able to identify is you should be able to name which is the opposite side, which is the adjacent side, okay, in a right angle triangle. Then only you can go ahead with writing the ratios, okay, writing the trigonometric ratios. Now coming to the trigonometric ratios. So how do we write? So there are 6 ratios we have. Okay, so let me quickly draw a triangle here for you. So we have 90 degree here. So this is going to be the hypotenuse. Okay, A, B, C. Suppose this is theta. Okay, so here opposite to theta, this will be opposite. Okay, and adjacent to theta, we will write it as adjacent. Okay, so we have 6 trigonometric ratios. We have sine theta, we have cosine theta, we have tangent theta, we have cosine theta, we have secant theta, and we have cotangent theta. Okay, so this we can write it as short form: sine theta, cos theta, tan theta, cosine theta, this is sec theta, this is cot theta. Okay, so this we can write it in the short form. So now what is sine theta? It is perpendicular by hypotenuse, or you can write what is perpendicular, you can write it as opposite by hypotenuse. Okay, now cosine, cos theta is base by hypotenuse, or you can write adjacent by hypotenuse. Okay, now tangent is perpendicular by base. Now perpendicular is opposite, by base is adjacent. Okay, so whichever you feel easy, you are able to feel easy to write perpendicular by base, you can write, or opposite by adjacent also you can write. Okay, but you have to you should be able to locate the opposite and adjacent correctly. If here you go wrong, then all ratios will also go wrong. Okay, and cosine theta is just the reciprocal of sine theta. So sine theta was p by h, so this will be h by p. Secant theta, sec theta is reciprocal of cos theta, that will be h by b. Okay, and cot theta is reciprocal of tan theta, that is b by p. So here you will be having hypotenuse by opposite, this will be hypotenuse by adjacent, this will be adjacent by opposite. Okay, so these are the 6 ratios you have to keep in mind. I can write here also, you can write 1 by sine theta, here you can write 1 by cos theta, here you can write 1 by tan theta. Okay, even the reciprocals you should be able to identify. Okay, so these are the 6 ratios which you have to memorize, you have to understand. You don't have to memorize, actually you can easily first make a right angle triangle and locate all the sides, and you know where is the theta, and based on that you can name the perpendicular base and the hypotenuse. So now let me give you one example to make you understand how we write these ratios, how we solve problems on that. So if I take an example at a right angle triangle ABC, angle B is say 90 degrees. Okay, so I will make ABC, this is 90 degrees. So suppose this is given 24 centimeter, this is say 7 centimeter. So the question is find sine A, and also they are asking find maybe cos C. Okay, so here how do we solve? Now what is sine A? Now if A is the angle, if A is the acute angle, what is sine A? Perpendicular by hypotenuse, that is opposite by hypotenuse. Now what is opposite here? BC. Hypotenuse will never change, hypotenuse will remain same. Okay, BC by AC. Now do we have BC? We don't have BC, right? So we need to find BC. Similarly, cos. Now cos C. Now here C is the acute angle, right? Now here C is the acute angle. So for this, opposite will change. Or what is cos? Actually cos is base by hypotenuse. What is base here? Adjacent. Adjacent by hypotenuse. Now what is adjacent for C? 7. Okay. So that is BC by hypotenuse will not change AC. So here also BC by AC, here also BC by AC. So values will come same. But we need to find BC, right? Sorry. We need to find AC. Sorry, I went wrong here. So we need to find opposite here. For A was BC by AC. So here we need to find AC. We don't have AC, right? So we need to find the unknown side. So how do we find unknown side? Again, our Pythagoras theorem we have to use. Okay, so Pythagoras theorem is hypotenuse square is equal to perpendicular square by base square. Or here we can say AC square is equal to AB square plus BC square, which is AB square is 24 square plus 7 square, that is 576 plus 49, which will be 625. So here AC will be root of 625, that is 25 centimeter. Okay, so you can do root of 625 by the long division method, or you can do prime factorization method. Okay, any of the two methods you can use to find the square root. So here we got hypotenuse 25 centimeter. So here we can easily find out now sine A. Sine A we got BC by AC, it will be 7 by 25. Cos C also is BC by AC, 7 by 25. Okay, so like this we can find out the ratios. See now, here it was sine A, it was opposite by hypotenuse, so ratios the sides will change. The opposite and the adjacent sides will change. Similarly for cos C also, even though the values are same, but still the way you name the opposite and the adjacent will change. Suppose if I can maybe I change this. If I have to find cos A, cos is again base by hypotenuse. Now for A, if you need to find A, what will be base here? What will be the base is what? Adjacent by hypotenuse. Now adjacent will be 24 here, right? Adjacent side for A acute angle is AB. So AB, hypotenuse will not change, AC. So here you will get 24 by 25, right? So sin A value we got 7 by 25, but cos A value is 24 by 25 because the ratios are different. Sin A is opposite by hypotenuse, but cos A is adjacent by hypotenuse. Okay, so this is the way we make use of these trigonometric ratios to find the ratios, whatever the ratios if they are asking, or to find the angles. Okay, the angles of the right angle triangle. Okay. So if we talk about the applications of trigonometry, so as I told you that this is one of the important chapters in one of the important branch of mathematics. So obviously it will have many applications, right, in day-to-day life. Okay, so what are the applications here? One of the main application you find is to find the the height of the tall structures, height of the tall buildings or the poles, or height of the tree if you want to find out. Okay, or height of the lighthouse you have to find out. So we can easily find the height of the tall structures. Okay, second is in the navigation. Okay, navigation. So in GPS, right now, what is GPS? Global positioning system, right? So in GPS, satellites make use of the trigonometry. Okay, so they based on the distance of satellite is usually able to locate your position on the earth. So how they do it to find the location of your position, where are you located? So usually they do is make use of the trigonometric concepts here to find the angle or the distance, or they triangulate your position on the earth. So this way they use the trigonometry to find the location of your place. Trigonometry also has application in surveying. Okay, in surveying of the land to find the distance of the land. Okay, so here what they set up a baseline, and they will locate the angle, okay, or the distance of a certain different points from the baseline. So in this way they find the distance of that particular point from the baseline, and they are able to find the and it helps in mapping. Okay, it helps in mapping of a particular area of the land. Okay. In physics also, trigonometry has applications where it is used to analyze the angles through which the light is reflected or refracted. Okay, and to find the angle, in order to find the angle, when we find the angle through which the light is passing through the lens or the mirrors, okay, it is used in designing some of the instruments like telescopes or microscopes. And of course, in engineering, trigonometry has a major role in designing the bridges, okay, where it is used to find out the force or the tension in the cables. Okay, so it is used basically, how it works is converting the cables into the horizontal or the vertical components of the force, and they find out how much force or how much tension a cable is able to withstand in order to balance the bridge. So I hope you found this session helpful to you in order to understand the basics of trigonometry. So pick some questions in your reader and practice this trigonometric ratio questions, and it will be helpful for you, and you will be able to solve questions easily. So thank you. I will see you in the next video soon. Till then, bye bye. Take care.